All right, we're going to talk about coordinate proof. Now, in chapter 7, we've been talking a lot about the x and y axis, the coordinates, x and y coordinates. We talked about vectors, on coordinates. We went to the slopes and the y-intercepts, the distance formula, all that stuff that you use coordinates for, x and y points. Now, we're going to talk about those same principles, but we're going to use A's and B's instead of our X's and Y's, instead of numbers. So you can see how it's like A0, B, C, those kind of things instead of the numbers on the X and Y axis. We want to see how it would work for any vectors or any shapes or anything like that. So this first one says two vectors are represented by vector U and vector V. So you've got vector U, which just goes right here, and you've got vector V. Now U is at the bottom and V is this one. The components of vector U are A0. That means you go over A and up 0. That's a component. So our components tells me how much to go over, how much to go up. So I'm going to go over whatever A is, and then go up 0. Components of vector V are over to B and up C. Over the length of B and up the length of C. Find the components of the resultant vector. So basically, we want to find out what is this point right here going to be. That's what we got to figure out. So how far would I go over? Okay, how far am I going to go over to get to this point R? And how far am I going to go up? Is there a way to figure that out with these two coordinates right here? Well, we know that from this point down here, we know it's the point 0, 0. Okay, that's a given, right? Gave us the notes the origin 0, 0. To get to letter S right here, you had to go over a B amount, whatever B was. We had to go over that amount. So I could actually put a length of B right there, just to show that that's how far I'm going over to get to this letter S right here. I'm going over a B. I'm going up a C amount. So from here down up to here would be a C amount. I'm not worried about that right now. What I'm worried about is this B amount right here. I know my bottom vector went over A. My top vector went over B. I'm going to take this B right here and I'm going to move it down to here. Do you think that spot now actually goes where R is? It is. That's right, exactly where R would be. So how far did I go all the way over to get to R? I went over A plus a B amount. So whatever A was plus whatever B was got me over to this point right here. How far did I go up? I went up C because it didn't move anymore up. It stayed. So my new vector, this vector R, should be at A plus B. A plus a B to get me my horizontal, and then C gets me my vertical. So A over A plus B and up C. Now, if you remember from before, we had the term resultant vector. Okay, this is what we get when we add the components of vectors. Could be two vectors that we're adding the components of. Could be three vectors that we're adding the components of. So the result is what you get when you put them together. That's the result. So vector U, remember the half arrow is your vector. Vector U was A0. Vector U went over A and went up 0. Okay, so everybody's good there. We went over A amount, and then we didn't go up at all. We just stayed on the x-axis. Vector V, we went over B, and we went up C. We went over B, and we went up C. Whatever B was, it might be a 2, and then C might be a 4. We went over 2 and up 4. Whatever B and C were. We went over a B, and we went up a C. If I was to put a line under here and add these two vectors together, what do you get when you add your x components together? A plus B. What do you get when you add 0 plus c together? You get c. That's where we get this resultant vector from. This is vector r. It's the result of the two vectors when you combine them, when you add them together. That's your result. So you had it. You start over a, and you went over a plus b, and then you went up to c to get to that last point r up there. Resultant vector is what you get when you add the two components. So we saw the component of the first vector right here. Components of the second vector were right there. If we add those together, we end up with that one. Now a plus b you can't combine, you just leave it. Now if you knew the two numbers, if you knew what a was and you knew what b was, then you would know just to add those two together. And then if you know what c is, you're just going to put c in there. So now that's kind of a formula for us that if we figured out the numbers, we can know how to do it now. We just add the x's and we add the y's. Let's look at the next one. A couple of shapes. What is this first shape right here? Square. So we need to put some stuff on it so that we know that it's a square. As soon as they say square, the first thing you should probably do is put 4 tick marks. That's the first thing I would do when I know it's a square, because I want to make sure I know that all 4 sides are equal. You could also put in 4 right angles. A square has to have 4 right angles to be a square. Now, this bottom O right here is the point 0, 0. That's our origin. And point A is the point A0. Anybody know what point C would have to be then? Okay, think about what that C would be. Think about C.
0A.
Okay, why 0A?
Because it goes the same distance, but it just goes up.
Good. It's the same distance. This distance right here is an A distance, right? So let's just say, for the sake of numbers, let's say it was a 5. This would be 5, 0, right? So what would this one have to be? 0, 5, because you're going up the same amount. So this one has to be 0A. It's going to be the same amount, but up instead of over. So you're going over 0, you're going up A. So what does B have to equal then? Got to be over A and up A. Yeah, so that has to be AA. So there is your square. That's just the coordinates to figure out the coordinates of a square. What's the next shape? Equilateral triangle. What do we know about those? All 3 sides are equal. I'm just going to kind of highlight a tick mark down there at the bottom. And what about all 3 angles in an equilateral triangle? They're all 60s. Do you notice how this top 60 got cut in half, so it made 2 30s? Okay, so this isn't my origin again, 0, 0. And x is over A and up 0. So this length is A right there. What would z be? Same distance going the other way? Yeah, negative A0 is good. Okay, so this would be negative A0. Now the tricky one is y. That's the tricky one.
0 and 1.
Got an answer? I haven't heard it yet. I have not heard the answer yet. Y is a little tricky, because you either got to use SOHCAHTOA, because it's a right triangle, or you got to think about Pythagorean theorem, possibly, or you got to think about the 30, 60, 90 triangle. If you remember from back in chapter 5, we had 30, 60, 90 right triangles. There were 2 little formulas. The hypotenuse equaled 2 times the short leg. So whatever the short leg was, you double it, you get your hypotenuse. So that would tell me that this length would just be 2A. That length. That's not the vertical length. That's the hypotenuse. Just talking about length right now. Do we remember how to find the long leg? Because that's what we're looking for here. We're looking for the 0 long leg. We need to know what the long leg is. The long leg, you do something times the short leg. Radical 2, because there's 2 different angles. Oh, there's 3 different angles, right? So it's radical 3 times the short leg. Radical 3 times the short leg, because there were 3 different angles, not 2 different angles. So this right here, 30, 60, 90 triangles, these are your 2 formulas right here. So who can now tell me what y is? What is it?
0, a radical 3.
That is correct. 0, comma, a radical 3. We knew it was 0. It had to be 0 because we're going straight up. But it was short leg times radical 3 would be a times radical 3 would be going up the long leg. Now, if you had known the 2a and the a down here, you could have done a squared plus b squared equals c squared and solved for the b and got the same thing. But you didn't know that unless you knew the 30, 60, 90 formulas. So those really come in handy to kind of remember these formulas. Okay, the third shape is a parallelogram. Parallelogram. Let's see. We got J and we have L. So K should be easy, right? What do we think about K? We know 0, or the O down here is the origin. So what do we think about point K? Well, before we do that, let's write on the parallelogram what we know about it. What do we know about a parallelogram? The directions tell us, or the word itself says parallel. So that means these have to be parallel and these have to be parallel. So first thing I would do is put my arrows showing that these are parallel. That would be my first step. One arrow was parallel to the one arrow, 2 arrows was parallel to the 2 arrows. In a parallelogram, the opposite sides are also congruent. So that side is congruent to that side, and this side is congruent to this side. That is every parallelogram that happens. We also have with interior angles, opposite angles are congruent and stuff, but we won't put those in because we don't need that for this problem. But that might help you a little bit with K. How do we get to letter K? Anybody have any ideas? Ryan, what do you think?
Take the b distance and add it to the a distance.
Okay, so you're saying that this amount on the bottom was my a distance.
Yes.
And there's a little bit left over, but it doesn't look like that whole thing, right?
Right.
So it looks like it's just whatever we would use to get to B. So it's basically that distance right there. If we took that distance and we added it to here, which is actually a B distance, it's going to be the same amount going straight up. So then, what was K again? The A distance plus the B distance?
Yes.
And then what was the X value, or the Y value? Just C. It's going to be the same value as C. It's almost like the resultant vector we just did on the last slide. Here was your one vector, was the A. Here was your other vector, B. A plus B was my A plus B. C plus 0 was my C. And you have the same point there. So if you go over A plus the B amount, then you go up to C amount, you'll be at the last point up there, point K. All right, there's your parallelogram. Let's move to the triangle, the rectangle. It says use a coordinate plane to prove. That's the key word I want you to underline. Prove that diagonals of a rectangle are congruent. Prove that this diagonal is congruent to this diagonal. That's the goal here. Do we know what this point is right here? Well, we do probably, because we're going to go over A and up 0. Here's over 0 and up B. So this has to be over A and up B. So it's just going to be the point AB. So there is point B in our rectangle. Now, to get the length of each diagonal, this point down here is the origin, so 0, 0. I want to find the length of OB. OB. How do I find that length? How do I know how far it is from the origin to AB? The distance formula, that big square root would help us. That would be the best. I mean, you could do a squared plus b squared equals c squared, probably get the same kind of thing. It would probably still work, because you know that this has a length of a, this has a length of b, and you could do that as well. But the distance formula, when you have two coordinates, distance formula is pretty easy, because you can get the a and the b just by subtracting. So a minus 0 squared, that would be my x minus my x. Then I have my y value minus my y value, which is b minus 0 squared. So technically I'm going to get a squared plus b squared, which does not come out of the square root. If you remember your Algebra 2 days, a squared plus b squared is not a perfect square. You would need a middle term to have it be a perfect square. So that one is just going to have to stay the way it is. That's the distance of O to B. Now let's find the distance from C to A or A to C. Let's do AC. From A to C. So I could use my x2 minus my x1, 0 minus A squared. My y2 minus my y1 would be b minus 0 squared. 0 minus a would be negative a, and you still have to square that. B minus 0 would just be b squared. I don't need to put the b in the parentheses because it doesn't have a negative attached. But the a I need to put in parentheses because it has a negative attached. What is negative a times negative a? Positive a squared. So this right here is still going to come out as a squared plus b squared. What do you notice about the two distances? They're the same. You just proved that the two diagonals in any rectangle, why do I say any rectangle? Because I used letters here. I didn't put in a number and make it a specific rectangle. I used letters to show that this would work for every rectangle now. Every rectangle, the diagonals will be the same because the two distances came out the same. If you had used Pythagorean theorem, you would have got the same answer. You would have gotten them both becoming c squareds, and they would have both been the same amount. All right, so there was your proof for a rectangle, showing that the distances were congruent. Okay, prove that the length of a midsegment of a trapezoid is the average of the bases. Okay, the midsegment of a trapezoid is the average of the two bases. Now, these are horizontal lines, which makes it really easy for us to count over. We could easily do that. You could easily find this midpoint as well. What is this midpoint right here? Over 2 and up 4. 2, 4. I could have used the midpoint formula. 4 plus 0 is 4 divided by 2 is 2. And 8 plus 0 is 8 divided by 2 is 4. So 2, 4 was my midpoint from the formula there too. This point is over 13 and up 4. Those are midpoints. When you connect two midpoints, you get what we call a midsegment. So midsegments, and it's the theorem says that they're the average of the two bases. So let's find out what the midsegment is first. Midsegment equals. What if your trapezoid wasn't level straight across and it was like diagonal? You would have to use the distance formula. So you got to know how this distance formula works, even though we could just count straight across if we wanted to. We still need to know how the distance formula works. So I would do my 13 minus 2, x minus x, 13 minus 2 squared, 4 minus 4 squared, and solve it with that one. 13 minus 2 is 11, 11 squared is 121, 4 minus 4 is 0, and 0 squared is still 0. So you're going to get the distance of 11, which we could have gotten if we just counted. I could have counted straight across and got 11. I just want you to know that if this wasn't straight across, you would have to use distance formula. To get DC, which is my top base, to get DC, I would do 12 minus 4 squared and then I have 8 minus 8 squared. So you're actually just going to get 12 minus 4 is 8. 8 squared is 64. And then the square root of 64 is back to 8. So this length on top is 8. This length was 11. We found that by using the distance formulas, but you'd get the same answer if you just counted. And then A to B is 14 minus 0 squared. And then 0 minus 0 squared. 14 squared is 196. The square root of 196 is back to 14. So this bottom one is 14. Is the midsegment the average of the two bases? How do you find the average? Base 1 plus base 2 divided by 2 equals the average, right? If you want to get the average of the two bases, you add them together, divide it by 2. So that's going to give me 8 plus 14 divided by 2. 22 divided by 2 is 11. And that checks because we just proved that the average of these two bases is the same as the midsegment. Now that will work for every trapezoid. Every trapezoid, you could add up the two bases, the top and the bottom, divided by 2, and that's what the length of the midsegment is. There's also one more thing that we know about the midsegment. Not only is it the average, but it's also parallel to both bases. If you connect two middle points, you're going to always be parallel as well. So parallel and the average of the two bases. Okay, got to move to the next one because we're going to finish this one before the bell rings. And it's got a few questions to it, so just want to get this one done. If you need it, it'll be on the website later. OABC is a quadrilateral. So follow me here. O to A to B to C is a quadrilateral, 4 sides. And it says all these other points are all midpoints. So D, E, F, G are all middle points. First one they want us to find is point E. So point E, let's see, how would I find point E? It's down here at the bottom. Let's write down our midpoint formula, just because we're going to be dealing with midpoints. The more times we write it down, the more likely we are to remember it. So what is my midpoint formula? Good. X1 plus X2 divided by 2 and Y1 plus Y2 divided by 2. There's your midpoint formula. Makes it easier if we have it on the paper. Okay, so find the coordinates of E. E is the midpoint of O and A. So we're going to add the two X's together. This O right here is the point 0, 0. So 0 plus 2A divided by 2 would be my two X's. 0 plus 0 divided by 2 would be my two Y's. So what is 0 plus 2A? 2A divided by 2 is just A. So we're going to get A, and then 0 divided by 2 is 0. So A0 is this point E down here. So this right here is A comma 0. And you can see that if it's 2A, half of that would just be A. So it is the midpoint. Find the midpoint of, or find the coordinate of point G. G is the midpoint of C and B. So C and B, we want to add these X's divided by 2, add the two Y's and divide by 2. So 2D plus 2B divided by 2. And 2E plus 2C divided by 2. That's going to give us our midpoint. What can we do up here for these? What can we do on the top here? We can take out a 2. And that 2 then would reduce with the bottom 2. The 2's would cancel out. So what's just going to be left over? It's just going to be D plus B because the 2's are coming out. So it's going to be D plus B is your X coordinate. E plus, should have been C, not D. Oh, it was a C. But when I put my parentheses, it made it look like a D. So this is actually 2C right here. Plus 2C. Okay, so it's E plus C right here. So that's your point G right there. So now find the coordinates of the midpoint of EG. EG would actually be this line right here from E to G. They want us to find the middle point of that. Okay, we know where E is, A0. We know what G is. G became D plus B on E plus C. So we want to find the midpoint of those. You add the x's and divide by 2. You add the y's and divide by 2. So you can actually look right here. Here's my two x's. They're right on top of each other. So A plus B, or A plus D plus B divided by 2. This was my first x. This was my second x. Those are my two x's. And then 0 plus E plus C divided by 2. I don't need to put the 0 in there because when you add 0, it doesn't change anything. So this right here would be the coordinate of that middle point of EG. Nothing you can reduce there. Completely reduced already. I just added this x1 plus this x2 divided by 2. I added this y1 plus this y2 divided by 2.
Why did you put a 0 at the bottom?
That's a 2, sorry. Looks like a 0, you're right, it was a 2. Alright, let's find D. D is the middle point of O and C, so 0 plus 2D, 0 plus 2D over 2, and 0 plus 2E over 2. So let's reduce that. What's 2D divided by 2 going to give me? Just D. And 2E divided by 2? Just E. So D and E would be point D right there. So let's put that in. D, comma, E. Okay, point F. Point F is the midpoint of A and B, so 2B plus 2A. We'll put 2A plus 2B over 2, and 2C plus 0 over 2. 2C plus 0 over 2. So I can take out the 2's here and cross them out. So I'm just going to end up with A plus B. A plus B is my x coordinate. 2C divided by 2 is just C. Now, point F, or the midpoint of DF, would be what you would get when you combine these two together. You want that midpoint. And you want to get that midpoint. You're going to add the A plus B plus the D. A plus B plus the D. That's your x part. And then E plus C is your y part. And divided by 2 for both of those. X plus x over 2, y plus y over 2. What do you notice about these two answers? They're the same answer. So this midpoint should have been right there because it's the midpoint for both. So when you connect opposite midpoints in every quadrilateral, you'll meet at the same point. Take a quadrilateral, connect the two opposite midpoints, you'll always meet at that same exact point. So that's the little proof there. All right, so 7-5's notes are done.